Welcome back to Kafka Internal's Crashcasts. I'm your host, Sheila, and today we're continuing our journey through the core concepts of Apache Kafka. In our previous episode, we delved into topics and partitions. Now we're moving on to another crucial component of Kafka's architecture: brokers. Joining me as always is our Kafka expert, Victor. Hey Victor, are you ready to break down brokers for our listeners?
Hey Sheila. Absolutely, I'm excited to dive into brokers. They're like the backbone of any Kafka cluster, so understanding them is key to grasping how Kafka works as a whole.
Great! Before we start, I'd like to pose a quiz question to our listeners. Here it goes. How many brokers are typically needed for a fault-tolerant Kafka cluster? Think about that as we explore the topic, and we'll reveal the answer at the end of the episode.
That's an interesting question, Sheila. It touches on some important aspects of Kafka's architecture and reliability. I'm curious to see what our listeners will come up with. Let's dive into the topic and give them some context to work with.
Sounds good, Victor. Let's start with the basics. What exactly is a broker in the context of Kafka?
Great question, Sheila. In simple terms, a Kafka broker is a server that's part of a Kafka cluster. Think of it as a librarian in a massive library. Just as a librarian manages books, a broker manages messages. It stores them, handles requests from producers to accept messages, and serves them to consumers when requested.
That's a helpful analogy, Victor. So, if brokers are like librarians, does that mean each broker is responsible for all the messages in the Kafka cluster?
Not exactly, Sheila. Each broker is responsible for a subset of the total data. Remember our discussion about partitions in the last episode? Each broker hosts some of the partitions from various topics. It's like each librarian being responsible for certain sections of the library, rather than the entire collection.
I see. So, what are the main responsibilities of a broker?
Brokers have several key responsibilities. 1. They receive messages from producers and assign offsets to them. 2. They store messages on disk for a configurable amount of time or until a size threshold is met. 3. They respond to fetch requests from consumers and serve them the requested messages. 4. They manage partitions and handle replication of partitions between brokers. 5. They participate in leader election for partitions.
Wow, that's quite a list. It sounds like brokers are doing a lot of heavy lifting in a Kafka cluster. Are there any specific configurations that are important for brokers?
Absolutely, Sheila. There are many configuration options for brokers, but some key ones include broker.id, a unique integer identifying the broker in the cluster; log.dirs, the directory where the broker stores its log files; zookeeper.connect, the zookeeper connection string, though this is changing with the move to Craft; num.network.threads and num.io.threads. These control the number of threads for network and I/O operations, which can affect performance. These configurations can significantly impact the performance and behavior of the broker.
That's fascinating, Victor. You mentioned that broker.id is a unique identifier. Does this mean each broker knows about the others in the cluster?
Great observation, Sheila. Yes, each broker is aware of the others in the cluster. This awareness is crucial for things like partition replication and leader election. When a new broker joins the cluster, it registers itself and gets information about the existing brokers and topics.
That makes sense. Now, let's talk about scalability. How do brokers contribute to Kafka's ability to handle large amounts of data?
Excellent question. Brokers are key to Kafka's scalability. You can add more brokers to a Kafka cluster to increase its capacity and throughput. When you add a new broker, Kafka can redistribute partitions to balance the load across all brokers. This allows Kafka to scale horizontally, handling more topics, partitions, and messages as your needs grow.
That's really powerful. But what happens if a broker fails? Does it take down the whole system?
That's where Kafka's fault tolerance comes in, Sheila. Kafka is designed to be resilient to broker failures. Remember how we talked about partitions being replicated? If a broker fails, other brokers that have replicas of its partitions can take over. The cluster will automatically elect new leaders for the partitions that were led by the failed broker.
I see how this ties back to our quiz question about the number of brokers needed for a fault-tolerant cluster. Speaking of which, I think it's time we revealed the answer. Victor, would you like to do the honors?
Certainly. The typical answer for a fault-tolerant Kafka cluster is at least 3 brokers. With 3 brokers, you can have a replication factor of 3 for your topics, meaning each partition has 3 copies spread across different brokers. This setup can tolerate the failure of any single broker without losing data or availability.
Thank you, Victor. That's been an illuminating discussion about Kafka brokers. Before we wrap up, do you have any interesting facts or anecdotes about brokers to share with our listeners?
Actually, I do. The term broker has an interesting origin. In financial markets, a broker is an intermediary who buys and sells securities on behalf of clients. Similarly, in Kafka, brokers act as intermediaries, handling message transactions between producers and consumers. The name was likely chosen to reflect this similar role of facilitating transactions.
That's a great bit of trivia, Victor. To summarize today's episode, 1. Brokers are servers in a Kafka cluster that store and manage messages. 2. They handle requests from producers and consumers, manage partitions, and participate in replication. 3. Brokers are crucial for Kafka's scalability and fault tolerance. 4. A typical fault-tolerant Kafka cluster requires at least 3 brokers. In our next episode, we'll be discussing Zookeeper's role in Kafka and the transition to K-Raft. For those unfamiliar, Zookeeper is a centralized service for maintaining configuration information and providing distributed synchronization. Thank you for listening to Kafka Internals Crashcasts. If you found this helpful, please subscribe and leave us a rating. Until next time.